Hey Panthers, we are taking a look at section 3.2, which is estimating decimals, and our learning objective for the day is that by the end of this lesson we should be able to estimate decimal sums, differences, products, and quotients. So we're estimating, which I know many of you have already done in the past. We're looking at decimal values, so numbers that have a decimal point and values that are less than 1. And we're going to be estimating by, if you recall, sums means to add. So we're going to be adding decimals together. Differences means to subtract. Products, that's the answer to a multiplication problem. And quotients is the answer to a division problem. Panthers, I'm going to go ahead and write the vocabulary term here for clustering and front-end estimation. What I would probably do is go ahead and fast forward till I get the entire definition written down, and then just pause so you have a minute to write it down. But clustering is a method used to estimate a sum when all addends are close to the same value. Okay, go ahead and pause me and finish that. A method used to estimate a sum when all addends are close to the same value. I'm going to go ahead and complete the definition for front-end estimation, and then I'm going to talk to you about it. Front-end estimation is an estimating technique, and I apologize for the board. Obviously, the smartboard, we're having some issues with the writing. No worries. An estimating technique in which the front digits of the addends are added, and then the sum is adjusted, oh boy, for a closer estimate. Okay, so go ahead and pause me and get those filled out. Again, clustering is a method used to estimate a sum when all addends are close to the same value. Addends are the numbers that you're adding together. Front-end estimation is an estimating technique in which the front digits of the addends are added, and then the sum is adjusted for a closer estimate with the back end of the number. Clustering is a method that we would use when you have, if say you're adding a bunch of numbers together and they all tend to be right around the same number. Panthers, go ahead and write this on the side. Let's say we have 10 and 4/10, 9 and 2/10, 11 and 5/10, and 10 and 9/10. So we have all these numbers are pretty close together, so we might consider using a clustering technique. Please keep in mind that when we're estimating, the idea behind estimation is to make this a quick mental math problem. So clustering says if all the numbers are pretty close together, then pick a number that's kind of in between and round it all to that. So what I would probably do is all the numbers are pretty close to 10. So I would round this to 10, cluster that to 10, that to 10, and that to 10. Now we know if I were to round these to the nearest whole number, these obviously would not all round to 10, but clustering is a quick technique we use that if the numbers are close together, round them all to the same thing, and then we can quickly know that this estimation would be 40. If we round everything to 10, we have some numbers that are higher and we have some numbers that are lower. And And so it all kind of works out. That's the clustering technique. Front-end estimation I'm going to use with you in an example coming up. So let's go ahead and move on down and take a look at example 1. It states that Nancy wants to cycle, ice skate, and water ski for 30 minutes each. That sounds important. I'm going to go ahead and circle that. 30 minutes each. About, Panthers, that word is telling us we're not looking for an exact answer here. We can go ahead and use estimation. So about how many calories, here's my question, how many calories will she burn in all? And then we have some data. When she cycles, she burns 165 and 5/10 calories. When she ice skates, she burns 177 and 5/10 calories. And when she's water skiing, she burns 171 and 5/10 calories. So I'm going to go ahead and circle all of these important numbers. Again, we know that she wants to do each of these for 30 minutes each. We're trying to figure out how many calories she'll burn. So what we would do this time, we rewrote our data up and down. Okay. And what we're going to do is ask ourselves first, are all of these numbers pretty close together? Is 165 and 5/10 close to 177 and 5/10 and close to 171 and 5/10? Hopefully you're saying yes. So you should be then asking yourself, what easy number that we could add by, are they close together? You can see here that the book chose to cluster and use the number 170. So it rounded all of these values to 170, not because that's what it would be rounded to the nearest whole number, because it makes it easy for us since these values are all close together. So what we're going to do is the add-ins all cluster right around 170. So to estimate the total number of calories, we went ahead and rounded each value to 170, and then we're just going to add that. Again, it makes it an easier problem to solve. So 170 plus 170 plus 170, if you can do it off to the side, or obviously take a look at my answer, but you would get 510. So our final answer is, going back to the question was how many calories will she burn in all? Nancy burns about 510 calories in all if she were to do 30 minutes of each of these. Okay, that's a pretty good workout for an hour and a half. Let's move on down to example 2. Now this estimation technique is one that you're probably most familiar with. It's asking us to estimate by rounding to the indicated place value. So Panthers, those of you who are still a little uneasy about your place values, you may want to remind yourself, and you can go ahead and include this in your notes, and I'm going to do this vertically just because I don't have a whole lot of space here. But remind yourself the different place values. So again, if you turn your head sideways, and this is our decimal point, this would be the ones place value, times 10 would be 10, times 10 would be 100. Working back the other way, 1 divided by 10 would give us tenths. Don't forget that THS. Divided by 10 again would give us hundredths. Divide that by 10, you get thousandths. And again, for those of you still working on those place values, I did post a couple of games on Google Classroom. Go ahead and take them out. Check them out. They're kind of fun. So taking a look at example 2, what we're going to do here, if you look at A, we have 7 and 13 hundredths plus 4 and 68 hundredths, and the directions tell us to round this to the nearest ones place value. So Panthers, what we're going to do is we're going to round these to the ones place value first, and then do the operation that's indicated or add. So directions off to the side here. We're going to be rounding to the nearest whole number. The ones place value tells us that we're going to round to the nearest whole number. So when we do this, just a reminder to you, if we're rounding to the ones place, let's go ahead and underline the digits that are in the ones place value. So for A, 7 is in the ones place value, and 4 is in the ones place value. And I want you to take a look to the right of that place value, because that number is the boss. That is the number that tells the previous number what to do. So if we look at 7 and 1300ths, the boss is number 1. The boss is saying, hey, do I keep this number at the nearest 1, which is 7, or am I closer to go up to 8? Hopefully you're thinking that would be 7. And the next add-in we have is 4 and 6800ths. The boss 6 is telling the 4 to stay at 4, or is it closer to 5? Hopefully you're saying closer to 5. So we round to the nearest whole number, and then we're going to go ahead and add these. 7 plus 5 then becomes a quick mental math problem, and we get 12. So the sum is about 12. Letter B. We have 9 and 705 thousandths minus 2,683 10,000ths. And this time we're going to round to the nearest tenths place value. So Panthers, remember when we round these, the last digit in our rounded answers are going to be in the tenth place value. In other words, there'll only be one digit behind the decimal. Let's go ahead and underline the digits that are in the tenths place value. For the first one, 7 is in the tenths place value. And for the second number, 2 is in the tenths place value. I'm going to put an arrow down for our bosses. Those are the numbers to the right. So for the first one, the 0 tells the 7 to keep it at 9 and 7/10 or go up to 9 and 8/10. The 0 says keep it down, keep it down. And the second one, the 6 tells the 2, keep it at 2/10 or is it closer to 3/10? Again, hopefully you see the 3/10. The ruling again, 5 or higher, round up, 4 below, keep it low. And so we round to the tenths. That was the first thing we did. And then, now that we're going to go ahead and add and subtract, because we have decimals, and we'll get to this lesson coming up in section 3.3, when you're adding and subtracting decimals, Panthers, I want you to notice something here, and that is simply, I think I'm going to have some issues here, is that the decimal points are lined up here. Okay, the decimal points are lined up. So that's very purposeful. We'll learn more about that. But we align the decimals. And once the decimals are aligned, then you can go ahead and add or subtract. So 9 and 7/10 minus 3/10, 7 minus 3 is 4. And we have our decimal points lined up, so we bring it right down below it to keep them all lined up. And 9 minus 0 is then 9. So our grand answer, Panthers, is 9 and 4/10. Let's take a look at example 3. Here we are estimating each product or quotient. Now these are a little bit different. Estimating products and quotients, we have a little bit of leeway as far as rounding. When you're multiplying and dividing, initially what we're going to do is probably round to the nearest whole number. Now sometimes when we round to the nearest whole number, they end up not being numbers that are easy to multiply and divide by. So we have to remember the whole point of estimation is to make this a mental math problem. So here we may end up changing the numbers slightly to make this easier to solve. So take a look at A. We're multiplying 33 and 83 hundredths by 1 and 98 hundredths. Now if I were to round 33 and 83 hundredths to, the nearest whole number, the 8 would tell me to round this up to 34. And 1 and 98 hundredths, the 9 would tell me to round this up to 2. Now some of you may be thinking, 34 times 2, I can solve that mentally, no big deal. However, If there's a number that's closer to that, that's very easy to multiply by, you can change it. So you can see here they actually rounded this to 35 instead of 34. Panthers, so I want you to think why that is. We've talked a little bit about numbers that are compatible with each other. In other words, numbers that add together well or multiply well. And remember we mentioned that 5 and 2 are good numbers to multiply by because when you multiply 5 and 2 we get that 10. So the book decided to round this to 35 because that was easier. So again, when you're practicing this, there really is no right or wrong answer. If you're changing your numbers way off, like in other words, you decided to estimate 33 and 83 hundredths and change it to 50, that would be not good. So let's do 35 times 2. Hopefully that's a mental math problem and you know that it's 50. And the reason we chose 35 is because 35 and 2 are compatible numbers. In other words, they multiply well together. So when we estimate 33 and 83 hundredths times 1 and 98 hundredths, we say that our answer is about, and we got 70. For B, we have 72 and 77 hundredths divided by 26 and 14 hundredths. I'm going to first round these to the nearest whole number to see if those are easy to divide by. So the 72 here, the 7 boss tells me to round this up to 73, and I apologize for the writing. And 26 and 14 hundredths says to keep this down to 26. Now, Panthers, is 73 a good number to be divided by 26? I'm thinking not. Hopefully you are. Can you think of some close numbers to 73 or 26 that are easy? And right now in my head I'm thinking quarters, like 75 cents and 25 cents. So instead of rounding this to 73, we rounded it to 75 because that's an easy number to divide by, especially when you're dealing with 25 as a divisor. So 75 divided by 25 is indeed 3. So again, why do we choose 75 and 25? Because 75 and 25 are called compatible. In other words, this time they divide well to each other. We didn't have to change the numbers too much. And again, this is just an estimation. So 72 and 77 hundredths divided by 26 and 14 hundredths is indeed about, not the real answer, 3. And the last one, this is where we're going to talk a little bit about front-end estimation. We have a big example here, Panthers, so stick with me. I apologize, this video is a little bit longer than I would have liked, but a lot of good information here. For example 4, this time we're estimating a range, okay? A range, if you recall, is the distance between the lowest amount and the highest amount. So here, we're going to kind of do an estimation and ask ourselves, what is the lowest it could possibly be, and what is the highest it could possibly be? And then your answer would be, our estimation is somewhere between 8 and 10, or whatever your answer is. So for this technique, we have to use that front-end estimation technique that we talked about at the beginning of these notes. Again, front-end estimation means that we add up the front digits and adjust based on the decimal values. So the steps for this is to add the whole numbers only. Okay, let's go ahead and do that. So here we rewrote our numbers vertically. We lined up our decimal places. Great job. And we're going to focus solely on the whole numbers right now. So we have 7, 36, and 5. So 7 plus 36 plus 5 is 48. Okay. We know that the whole number values, or we know that 48 must be less than the actual numbers, okay, because we have some decimal values to the end. So we know this is the lowest it could possibly be. So this is called an underestimate. Sometimes we'll do that to make a quick estimate, and we'll say we know our answer is at least 48. Okay. And then, so the exact answer right here of 7 and 86 hundredths plus 36 and 97 hundredths plus 5 and 40 hundredths is going to be 48 or greater. Okay, we know it can't be less than that, again, because of those decimal values. Now, we can estimate a range for the sum by adjusting the decimal part. So we dealt with the whole numbers. Now let's focus on the decimal values. And what we're going to do today is decide, should I round this down to 0? Should I round it to 5/10? Or should I round it to 1? Again, same thing as 0, a half, or 1. So let's just time, we're going to just focus on the decimal values. And so we're looking here. The 8 would tell us to round this up to 1. The 9 would tell us to round this up to 1. And the 4 this time, we would typically round down to 0 here, but we have this extra option of rounding to a half. So is 40 hundredths closer to 0 or closer to 50 hundredths or 5/10? Again, hopefully you're saying 50 hundredths. So let's add these up again. These estimates now, 1 plus 1 plus a half is 2 1/2. And again, we could put a 0 here. It's the exact same thing. So what we did here is we added the decimal parts of the number. Okay. And then we're going to add the whole number estimate and the adjusted estimate together to get the highest part of our range. So thinking back again, we rounded the whole numbers to 48, or we added up the whole numbers and got 48. And then we are adjusting this by the estimation of just the decimal values. So 48 plus 2 1/2 will give us 50 1/2, or 50 and 50 hundredths. Okay. So the adjusted decimals are greater than the actual decimal. So 50 and 50 hundredths would be considered, this would be an overestimate. We know this is bigger than what the real answer is. It's an overestimate. And again, how do we know it's an overestimate? Because we rounded up, and we rounded up. Then you take these two values and it would be the answer for your range. We know the lowest it could be, just by adding the whole numbers, would be 48. We know the highest that it could be would be 50 1/2, or 50 and 50 hundredths. Panthers, this concludes our 3-2 lesson. Again, hopefully you're feeling more confident on estimating decimal sums, differences, products, and quotients. You do not need to do the try it. Okay. Thank you for completing your notes and have a great day.